Hey guys, welcome back to the Python PlayBook series. So in today's episode, we're going to be taking a look at a little bit more of a real world exercise. So today we're going to be taking a look at compound interest and how to implement that in Python. Now I'll put this exercise up at the end of my previous video, so for those of you who've had a chance to go through this, feel free to skip to the following timestamp to go and see the work through. But if you haven't had a chance, here's the exercise on screen now, so go ahead and pause the video, have a try at this, and then come back whenever you're ready. So before I actually go into the coding, I want to explain what compound interest is so you guys have a general idea before you tackle it. So let's say a person called Bob is putting some money into a savings account. Now let's say he puts £1,000 in. He will earn a certain amount of money per year, and he wants to know how much money he has after, let's say, 5 years. Now that certain amount of money that he earns yearly is given by the interest rate. Now, realistically, the interest rate varies from bank to bank. So this is why it's very important to look at compound interest, because a person who wants to open up a savings account, they want to see which bank has the best interest rate and therefore determine which bank to open a savings account in. All right, let's get into the code. So as you can see here, I've already got my lines commented, and I always mention this. This is very important. So if you're new to Python, I definitely recommend doing this. Alright, so as you can see here, we want to read the amount of money deposited into the account from the user. So if you guys remember how to ask the user to input something, we do input and then the question. But if we have a number that they need to input, then we have eval input. So let's just make a new variable, call it deposit. And then that equals eval input within the brackets. And then we have our question, which in this case is just how much money would you like to deposit. So now if I run this should open up a question and a spot to answer. So here we can just answer with, let's say 1,000. Now 1,000 has been now attributed to the variable deposit. So if you want to go and compute the amount of savings in the account after 10 years, we want to use the compound interest formula. So I'll put up the compound interest formula on the screen right now. Here it is. So as you can see, there are a few variables to uncover. So starting off with A is the final amount of money after however many years. So in this case, 10 years, how much money is left in the account. P is the original money that you deposited, which in this case was written to be 1,000. And then we have R. R is essentially a variable for the interest rate. And in today's exercise, we're taking the interest rate to be 10%. N is essentially how often does this interest rate apply. So some banks do it quarterly, others do it yearly, but since in this exercise we're doing it yearly, so we'll just take n equals to 1. And then we have n again in the exponent, but then we also have t. Now t refers to the time span over which you're doing this. And in this case, as I said, we're going to be doing it over 10 years. So now we have a rough understanding of the formula. Let's go ahead and implement this in Python. So let's just make a variable called final amount. So let's go ahead and start the formula. So we have p, which is essentially deposit. Deposit multiplied by. Now, for those of you who can't quite remember what the multiplication symbol is in Python, feel free to check out this video, which will go through all the arithmetic operations in Python, but it's the asterisk sign. That multiplied by the bracketed term, which in this case is 1 plus r over n. And as I said, r was the interest rate, and that is 10%. And n is the number of times that is compound interested, and as I said, n equals 1. Now, 10% needs to be represented as a decimal, so it will be 0.1 divided by 1, which is just equal to 0.1. And finally, we have the exponent, which if you guys remember, I went through in the previous video, we represent with 2 asterisk signs. So once again, n equals 1, so nt in the exponent is just equal to t, and as I said, t is 10 years. So if you go ahead and run this now, we can show that we do get the correct result. Just go to do a final amount and run this, and we'll see we get £2,593, and then however many decimal numbers after that. But of course, you'll have to go into a compound interest calculator online or do it manually. But just to save time, I want to repeat the calculation for 1 year rather than 10. There we go, 1,100. And that makes sense because 10% of 1,000 is 100, and add that on to the original amount, which is 1,000, is 1,100. Okay, so that's all well and good now. We've calculated the compound interest, but we want to represent it in a more neat and structured way. So as you can see here, what we want to do in the last line is display the amount in the savings account after X amount of years. So if you guys remember, in order to display anything in Python, we use the print command. So we do print, and a message we want to display is put in apostrophes. The message here in this case is after 10 years you have, and in order to output the variable value, we go ahead and put a comma followed by the variable. So in this case, the variable is final amount. So it says after 10 years, you have £1,100. But if you guys remember, £1,100 was for 1 year. So clearly something's gone wrong. So what I haven't done is essentially run through the entire page of code. And this is something very, very important to remember. Always, any change you make, always remember to go through the entire page of code, because these changes aren't accounted for, and Python still remembers the original code that you had because it hasn't run through the new line of code that you've put in. Because Python doesn't know the change you've made unless you run through it. So let's go ahead and run through everything again. It's going to do run, and then put in the number, which in this case is 1,000. There we go. After 10 years, you have £2,593 and however many pence. But you might be wondering, this number looks quite unneat and it's a bit ugly to look at. And money isn't represented like this normally. So what we have to do is round that number up to 2 decimal places. So I'll quickly show you guys on a new cell how to do that. So we go ahead and display it. So we want to do print, and then we'll put within apostrophes, the percentage sign, dot to F. So that has made it so that the variable is now 2 decimal places. Now, of course, you can change this to however many decimal points you want. I just use 2 here. We can change this to 3, 4, 5, 10. Doesn't really matter. But in order to finish this line of code, what we have to do is go and add in a percentage sign followed by the variable. In this case, the variable is final amount. So let's go ahead and do that. There we go. So if you go ahead and run this, we'll see that we have 2,593.74, which is the original number to 2 decimal places. Now, in order to go and put this back into our main line of code, we want to go and copy and paste this section here within the brackets, and then input that in the variable sector of the other print line. And now, if you run through this, there we go. After 10 years, you have £2,593.74. And there we go, we've done it. We've learnt how to calculate and present compound interest in Python. If you guys have any questions, feel free to let me know down in the comments below. And if you have any suggestions for other exercises that you guys have that I can tackle and go through in a separate video, feel free to let me know down in the comments below as well. Now, next episode's exercise is going to be interesting. It'll be up on screen now, so you can go ahead and tackle this at your own pace and then come back in the next episode where I'll be going through the solution. But for now, that's it from me. I hope you guys enjoyed, and I'll see you all later.